Good day to my fellow cosmate. I'm Cyrus Lee representing Group 1, and we have Lucas Lee and Mr. Muhammad Zaid along in my group. Today we are going to discuss about the communication principles of pulse modulations and multiplexing, which is guided by Dr. Yusri Bin Md Yunos. Okay, let me further present the pulse modulation. Pulse modulation introductions type of modulation, which signal is transmitted in the form of pulses used to transmit analog information, and continuous signals are sampled at regular intervals. The process of changing the characteristic of carrier signal like amplitude, frequency, and width, etc. And the process of adding information to the carrier signal. And the carrier signal is a steady waveform with constant amplitude and frequency, shown in the figure side here. Modulation signal, carrier signal, and modulated carrier signal. Okay, pulse modulation, there are two major types, analog and digital. Indication of sample amplitude is infinitely variable, widely used. So for digital, indicate sample amplitude at the nearest predetermined level. Okay, this is a sample of pulse modulation techniques. So the continuous waveform modulation, pulse modulations. So we are going to focus on this pulse modulation part for today, and in analog modulation and digital modulations. There are three different types of analog modulation and digital type modulation with some new technology of digital modulations. Okay, pulse modulations, pulse amplitude modulations, pulse width modulations, pulse position modulations. This is three types we are going to discuss for today. I'm going to present for this PAM, pulse amplitude modulation, and pulse width modulation, PWM. Okay, PAM, basic form of pulse modulations, regular intervals, and each sample is made proportional to the amplitude of the signal at the instant of sampling. Okay, PAM signal follows the amplitude of the original signal. Then a signal traces out the path of the whole wave. Then signal which is sampled at an Nyquist rate can be reconstructed by passing it through an efficient low pass filter with exact cutoff frequency. So you need to know the exact cutoff frequency. So it's very easy to generate and demodulate. The technique of transmits the data by encoding in the amplitude of a series of signal pulses. Okay. PAM, also there are two types of PAM, single polarity and double polarity. Single polarity, fixed DC level at the signal so that the signal is always positive. Double polarity is both positive or negative pulses. Okay, this sample of PAM, the waveform, message signal, sampling signal, and PAM signal. Okay. Okay, advantage of PAM. Modulation and demodulation are simple, easy to construct for transmit and receive circuit. So simple to process both modulation and demodulations. Generate pulse modulation signal can be carry the message at the same time, and data will transmit quickly, efficiently, and effectively through usual copper wire in mass volume. Quite costly actually. So both transmission well as reception doesn't require complex circuitry. Both circuit design of transistor and receiver is very simple. Okay, disadvantage: last bandwidth require more noise, amplitude is varying, then require more power. Then transmitting PAM signal PAM must be very large. The bandwidth must be very large. Frequency change based on the message modulating signal because of these changes within frequency of the signal. So intrusion will be there, intrusion. Noise immunity is very low compared to other types. It's nearly equivalent to AM. So the pulse amplitude signal changes. It requires power for transmission is high, and even get the PAM more power is necessary. So application of PAM, mainly used in Ethernet communication. Microcontroller use this technique in order to generate control signals. Use photobiology, so as an electronic driver for LED circuits. modulation technique is mainly used in digital data transmission and application changes by PCM to PPM. So all 4 modems with faster above 300 bits per second utilize QAM quadrant amplitude modulation. Okay. PWM. PWM acronym used for pulse position modulation. Okay. Timing characteristic is made proportional to the amplitude of the sample signal. Variable characteristic can be either frequency, position, or width. Pulse time modulation can be classified into 3 types. Like PAM, this technique, the amplitude of the signal is constant and only the width is varying. So similar to frequency modulation as the variation in width of the pulses. The frequency of the pulses in PWM signal shows variation different. So this is a sample of graph showing the message signal, sampling signal, PM signal, PWM. Okay, advantage of PWM, low power consumption, efficiency very high up to 90%, less interference of noise, high power handling capacity, it's more immune to channel induced noise than PAM, so more immune, more better than PAM. Noise added to amplitude task of reconstruction PWM signal from distorted PWM signal is more easy, and the transmission and reception do not need to be synchronized. Okay, disadvantage of PWM. The circuit is more complex. We can see the voltage spike. The system is expensive, uses a lot of semiconductors, devices. Switching loss will be more due to high PWM frequency, and bandwidth it can be somewhat larger than PMM. The bandwidth is larger than PAM. Okay, PWM application used in encoding purposes in the telecommunication system, control brightness in the smart lighting system, used in speed control in fans, prevent overheating in LED while maintaining its brightness, in audio and video amplifiers. I think that's all from me. Mr. Lucas will continue this pulse position modulation slide.
Okay, Doctor, I will be representing for the group 1 pulse position modulation PPM. Okay, both the amplitude and the width of the pulse are kept constant. The position of each pulse with reference to a particular pulse. Example, they reference a particular pulse. A single pulse is transmitted with the required number of the phase shifted. It can say that the pulse position modulation is an analog modulation scheme where the amplitude and width of the pulse are kept constant, while the position of the pulse with respect to the position of a reference pulse is varied according to the instantaneous value of the message signal. PPM can be obtained from pulse width modulation. This is done by getting rid of leading edge and body of the PWM pulses. Okay, next slide. Okay, this is the graph show the waveform of the analog sample pulse and the PPM. Okay, next. Okay, the advantage of the PPM, as we know, it has a constant amplitude noise interference is less and easily separate the signal from the noisy signal. Among all 3 types, it has the most efficiency power and require less power when compared to pulse amplitude modulation PAM, and better noise immunity as compared to PAM. Okay lah, repeat. As the amplitude and width of the pulse remain constant, thus the transmission power also remain constant and does not show variation. And the recovering PPM signal from distorted PPM is quite easy. Interference due to noise is more minimal than PAM and PWM. Next. And the disadvantage of the PPM, the system is highly complex and require more bandwidth. In order to have a proper detection of the signal at the receiver, transmitter and receiver must be synchronization. Next. Okay, this slide is the PPM pulse position modulation. For the application, it used to the air traffic control system and telecommunication system, and also remote control cars, plane, trains use the pulse code modulation. It is used to compress data and for storage use and optical communication system in radio control and military application. Next. Okay, this is multiplexing. I will continue my talk. This is the introduction of multiplexing as we know, or it's called muxing. MUX is a way to sending multiply of signal and string information over a communication link at the same time in the form of a single complex signal. When the signal reaches its destination, a process called demultiplexing or demuxing recovers the separate signal and output them to individualize. You can see from the figures beside. Okay, next. Okay, as the introduction, it can use in the network to consider multiple signal, digital or analog, into a single composite signal that is transported over a common medium such as a fiber optic cable or radio wave. But now commonly we're using the fiber optic, more easy. When the composite signal reaches its destination, it is demultiplexed and the individual signals are restored and made available for processing. When various signals send the traditional channel, hence it a prospect of collision, the multiplexing concept is used to avoid such a collision. Next. Okay, the ideology of the multiplexing networks use variety of multiplexing technique, but conceptual level, they all are operate in a similar manner. The individual network signal are input into a multiplex MUX that combines them into a composite signal, which is then transmitted through a shared medium. When a composite signal reaches its destination, a demultiplexer splits the signal back into the original component signal and outputs them into separate lines for use by other operations. Next. This is the application for the multiplexing type. As we know, used in the industry and both analog and digital communication, and it first was introduced at 1870s to support the telegraph, but now become mainstream in telecommunications such as radio, television, and telephones for our communication use, and even the computer networks. Next. And it is a greater signal that can transmit over a single channel. It can be either many channel we can use and utilize the bandwidth of a medium effectiveness, and no multiplexing is used between the clients at two several distance apart. It would require separate connection lines, save cost, and it's also given one line we needed, and this lead to reduction in the line cost. Okay, what are the types of multiplexing? Now in the organization, we can select multiple forms of multiplexing. We can choose with the larger parts of the signal that been transmitted analog or digital, and the media used to carry the transmission, such as a coaxial fiber optic cable or microwave link. And overview multiplexer techniques, which further divide into a frequency division multiplexing FDM we call, and the wavelength division WDM, and time division multiplexing, three types. And the TDM is further separate into two types, which is synchronizing and asynchronous. Okay, next, this is the multiplexing graph, as we can see from the figure. From the analog have FDM and WDM. For the digital only have TDM, and we have synchronous and asynchronous. Next. And the multiplexing for the analog type, we have the frequency division multiplexing. This is the bandwidth between a communication link that divided in the subchannel difference frequency with carrying a signal in a parallel to the another signal. And analog radio transmission commonly use FDM to multiplex the signal across the radio wave. And analog cable TV also use FDM to sending multiply channel down the same strands of the coaxial cable. And offshoot of the FDM, orthogonal frequency division multiplexing, or FDM, which transmit sub-channel frequency closer together while enabling them to overlap and remaining separate. And this is the graph of the wireless transmission comparison for the FDM, and single channel. We can see the graph have a big difference. Okay, next I think will be presented by my other colleagues, and Mohammed Zaid will be presenting the next slide. Thank you.
Okay, thank you, my friends Lucas and Cyrus. And I will continue multiplexing the analog with wavelength division multiplexing (WDM). Multiple communication channels are concentrated and transferred on light waves with different wavelengths. Conceptual dissimilar with FDM, except that FDM is described in the terms of frequency radio or television broadcasting. For example, where WDM is specific to wavelengths. The WDM approach is more common in telecommunication system and computer network that the user laser system to send light signals over fiber optic cables. WDM variation include coarse WDM and dense WDM. DWDM, which put fewer or more channel of information respectively on the medium at the same times. Next. Time division multiplexing (TDM). In a group of digital, multiple digital signals are transmitted over the same channel in alternating time slots. TDM operates at the temporal level, unlike FDM and WDM, while operate at the frequency or wavelength level. Although TDM as its root is in telegraphy, it is now commonly used in digital telephony to transmit multiple conversations across a common medium. TDM is also used on synchronized optical network links, which were once the mainstay of enterprise WAN and internet connectivity. TDM can be either synchronous or asynchronous. Next. Synchronous TDM. The input is connected to a frame. If there are n number of connections, then the frame is divided into n time slots. Each slot is allocated for individual input line. The sampling rate is common to all signals, and some clock input is given in this technique. The marks always allocate the same slot to each device. Asynchronous TDM. The sampling rate is different for each of the signals, and the clock signal is also not in common. If the allotted device for a time slot transmits nothing and sits idling, that slot is allocated to another device like asynchronous. Next. Digital, new technology, code division multiplexing, CDM. A sequence of bits called the separating code is assigned to each signal to distinguish one signal from another. The separating code is combined with the original signal to produce a new stream of encoded data, which is then transmitted to a shared medium. A demarcs that knows the code can then retrieve the original signals by subtracting out the spreading code, a process called dispreading. CDM is widely used in digital television and radio broadcasting and 3G mobile cellular networks. 4G and 5G primarily use OFDM. CDM can also support multiple signals from multiple sources, a technique known as code division multiple access. Next. Space digital multiplexing, SDM. Signal paths are spatially separated through the usage of multiple conductors, such as optical fibers or electrical wires. The conductors are bundled into a line transport medium but are physically separated, with each conductor handling a transmitted channel. Individual conductors can be further multiplexed through the usage of FDM, TDM, or other techniques. SDM is often used submarine cables to help increase capacity, but it can also be used for wireless communication. Next. Polarization division multiplexing, PDM. Incoming electromagnetic signals are polarized into the orthogonal channels that are transmitted through a common medium. PDM is frequently used in fiber optic communication as well as radio and microwave transmission. For example, satellite TV providers then use PDM to deliver TV signal to satellite dishes. Next. Advantage of multiplexing. A wave and signal can be transmitted over a single medium. The utilization of a medium bandwidth can be very effectively. Multiplexing enhances the network's economic stability because it reduces both the time as well as cost required for the operation of the physical medium when a single medium serves many signals or subscribers or applications. In telecommunication, multiplexing plays a key role to reduce the cost of networks through reducing the number of communication links required among 2 points. Next. Summary. The advance of technology help to reduce the instrument or equipment used to transmit data and increase the data transfer size and rates. Help to improve the efficiency of data being transmitted from a place to the other place without losing the details or being interrupted by the distortions. It also link the data transfer more effective and accurate with lower cost of setting up the telecommunication system. It will also improve the quality of the service to the service provider and satisfy the consumer's needs such as the area of information sharing like e-conferencing and e-commerce and etc. Next. Thanks for listening.
Yeah, thank you, Doctor, for teaching us. Thank you. We are group number one.
Thank you, Dr.